Hi, my name is Miranda Williams, and this is Lab 4 on oscillations with a spring. So, the purpose of our lab was to build a computational model based on a video of an oscillating spring with a mass attached to it. Within our computational model, we included the change in kinetic energy, the gravitational potential energy, the spring potential energy, and the total energy over time. The main physics principles that were used within this lab was the gravitational potential energy, spring potential energy, kinetic energy, Newton's second law that mainly surrounds the position update and the velocity update formulas. And this is a preview of what our data looks like in the end after we built our computational model off of the oscillating spring. So these were the main physics ideas. We calculated kinetic energy because that was a component of the spring and the mass. We also did gravitational potential energy because that was part of our system. We also did the spring potential energy because that was also included in our system as well. And we did the position update and the velocity update formulas for Newton's second law. So this is our computational model, and these are our initial conditions. The ball mass was 0.402 grams. Our ball position was these coordinates, and then our ball velocity. Most people started with 0 for their initial velocity. However, I started my video off whenever the mass already had velocity, so that's why my velocity already has numbers. And here is again our model of our our code, sorry. The system of the experiment was the Earth plus the oscillating spring, and there were no surroundings. So here's more of our computational model. So as you can see, we did all of the equations based off the kinetic energy, the gravitational potential energy. We also did the spring potential energy, and then of course we did the total energy, which was of course the sum of all of the energies. Um, we also included F grav and F spring within this, and then our F net was our gravitational force plus our spring force. And then as you can see here, again, we have our velocity update formula and our position update formula for Newton's second law. And then we also have the different components for the spring. We have L, we have L hat, and then we also have S as well. And then over here on this side, we also have our key constants that we needed. So we have our gravitational constant, which is 9.8. And then we also have our spring constant that was given to us. We also have the relaxed length of the spring as well. And then again, the components that make up spring force, which is L hat, S. And then we also just have the equations again for kinetic energy, gravitational potential energy, spring potential energy, and then the sum of our energies, which is kinetic, gravitational potential, and then spring potential energy. So sources of error within my experiment was tracking the oscillation of the spring after it already had gained some velocity. Also applying a force to the spring while letting go of the object attached to the spring as well. My energy principle was satisfied in my model because my model showed that the energy was 0. So that means that all the energies are balanced, therefore my energy principle is satisfied. And then based on my data from Tracker, the period of oscillation from the X position was only 0.33 seconds. However, the period of oscillation from the Y position was throughout the whole 9.21-second video because the Y value alternates between two values, so you can tell that there is oscillation within that. The period of oscillation is different between the X position and the Y position because the oscillation of the spring is in the Y direction and not the X direction.